Hello, ladies and gentlemen. This is Code Courageous. Code fearlessly. Now, basically, the point of these videos, at least the first videos I'm putting up here on my channel, is to basically engage you, get you excited about coding extemporaneously. So what that means is we need to be able to take our problem, ingest it, and start solving it fearlessly. Now, without further ado, I basically made this problem actually within the last few days, and I tested it out on myself and so forth. And just specifically, it is synthetic division. And you're not going to be asked to come up with the algorithm. I'm going to give that to you. The point of this is basically to give you an exercise that's sort of like what we had gone through, or at least, well, anyway, I'm not going to refer to anything else right now. There is a purpose, there's another class or whatever that I'm designing this for. And there's a cohort of us who worked on these similar problems and coding in Ruby. So what we're going to do is we're going to take this synthetic division algorithm and we're going to code it up in Ruby, and we're also going to address issues of formatting. Okay, so I think this is a great problem because it basically it gets to the point. In other words, the synthetic division algorithm is simple. So we don't want to get into how to devise an algorithm. What we want to do is to get into how do we basically start to solve a problem in front of someone else live and without having the safety net of an editor to help us. The other thing about this problem that is quite interesting, or as you see me solving it, is we're also addressing issues of keeping the type consistent. So type inconsistency is going to be basically a source of errors. And what we want to do is to try to reduce those errors as quickly as we can see or identify them, or see them coming. So right now I'm going to start off with what I'm calling this. I'm going to now define the problem that we're to solve, and then we're going to start solving it. Okay, so I'm calling our Ruby method find quotient, and it takes in an array, okay, which represents the coefficients of a polynomial that we're actually going to divide. So this would be representing the dividend, 3 is representing the divisor, and then we're going to get a quotient and a remainder. Now I'm going to start just basically giving you some background for what it is I'm discussing, because this obviously is not going to make much sense to anyone otherwise. Okay, so in the synthetic division algorithm, okay, you're basically going to receive a dividend, say p of x, and a divisor, x minus a. And this is a monic polynomial where the degree is 1. Now, a monic polynomial is one in which the coefficient of the term of the highest power, right? That coefficient is 1. And so it's important, at least within, to keep everything simple, we're just going to do synthetic division with a divisor that is a monic of degree 1. The other thing is that p of x could be pretty much any polynomial that we would like to divide. Okay. And there are many reasons that the polynomial is defined in this way, because it makes it quite, it facilitates the explanation of what pieces of it do. So I'm not going to go into great detail with that, but for an example right now, our dividend is, let's say, 3 times x to the third. So that's what this is representing. I'm going to write it out in the way that you would normally see it, but I'm just kind of doing this in this editor because we want to bring aliveness to this. I don't want it to be sort of like this editing thing where I'm constantly going to some other application and basically coming back to this, and it takes away from the now and liveness of this, and I'm trying to get at that. We're trying to build some code courage, so the idea is we want to do as much of this or explain as much of this as we can in real time, very few edits, and move this thing along. Okay, so in our synthetic division algorithm, okay, we again look at the form of our polynomial here, and then take a look at our coefficient array that we get from this polynomial. So we're building a coefficient array that is comprised of the coefficients of the polynomial, because that's basically all we need to define it uniquely. Okay, so we're taking the 3 here, the 2 here, the 5 here, and the -9, and we're making its own array out of that. Okay, and that's enough to uniquely define what this is. And then our divisor, all we need now is, in this particular case, the 3 out of that to represent this monic polynomial of degree 1. And okay, so this is where the algorithm comes in, and I drew this diagram here, which should be kind of clear. Anyway, the idea is we're treating everything in this whole matrix kind of paradigm to facilitate the understanding. This is of course, a one-dimensional array with 4 elements. In the ones that given the example that we've chosen here. So I'm just continuing. Okay, so in our algorithm, we take the divisor, right? And we multiply it by the quotient of as you could see, all of these, I've broken out this array into these columns, right? So at this column, what you do is you always go to the column before. Okay, you multiply that by the divisor, and then you put it beneath. Then what you do is you add those two, and you get the quotient array. So we're building the quotient array this way. So, for example, in the column index 1 here, right? Okay, what we're going to do is take the quotient of the index that was before it, multiply it by the divisor, we get 9, we add those together and we get 11, and so on and so forth. Now, up to the last one, and this actually represents the remainder. So this will be the quotient, and the last element of the array in the quotient represents the remainder. So I think what has to happen is you really should sort of kind of go through this on your own for a little bit to understand what's going on. Try this out, and then you go, oh, I understand. All right. So the next thing we're going to do is now we're going to get to the actual solving of the problem. All right, so find quotient. What we're going to do here is I'm working in Microsoft Visual Studio Code, which is a pretty neat editor to work in. There are many neat editors, but this is the one I'm working in right now. It's going to allow me to, I have basically configured it such that I can easily test out the algorithm in the terminal window below. We're not going to do that too many times because that goes against the code courage. Right now what we're supposed to do is we're trying to process this in our head as far as we can, address all the hallmarks of things that we might make an error in. Okay, so there may be things that will indicate that we know we might probably do to ultimately create an error. What we'll do is we'll read the code each line to make sure that all the types are consistent and consistent particularly with the methods that they work with as well. Okay, so let's create our Ruby solution for, oh yeah, I think what I want to get at also here is within find quotient, this has to be the output. 2 lines where the first line is the dividend that is basically formatted in this way. Okay, and then I want the second line to be the quotient and the remainder and everything looking like this. Okay, so let's start this thing off. I'd like to def find quotient, and what we are looking for, the first, okay, so see the first here, this is the coefficient array of the dividend, so we say dividend to keep that clear and clean. The next of this this just I guess 2-part operator here is it's the divisor. This is x representing x minus 3, so we put 3 here, and you'll see what it is I'm doing later. But if you know what, okay, we're going to put end. Okay, this is kind of long. The video is kind of long because there are a few things that we have to do here to ensure that everything works out right, and I want to address places where there will most likely be some kind of error, and we're going to try to clean all this thing up before we execute. And after we execute, hopefully we've addressed most of the problems, and we'll only have to debug a few things and we should be done. Okay, so not 3. I don't know why I said that. So it's the divisor. Okay. Now the first thing that we'd like to do is we need to have something that represents our initial case for the quotient, because when you take a look at, let's take a look at what we're doing here in the algorithm. Everything seems to be wrapped around what's going on here in the quotient. So, and it's based upon the dividend, right? So why doesn't this look like a map to you? It looks like you would probably use the map method in Ruby in order to actually manage the state of what we're doing to each of the elements of our array. So since everything seems to be referring to the dividend, why don't we address that? So before I start talking about what the initial, because you need to initialize a couple of things here. Before we start talking about that, let's just go into dividend. So we Okay, so dividend, what we want to do here is we want to start to address an enumerated version of this, okay, and then start operating on it. So we say dividend dot map, right? Because map allows us to be able to address each of the elements that we've enumerated and then basically put an object sort of in its place, you know, in reference to another array that's like it. So it's not going to destroy dividend. It's actually going to be mapping into another array that is analogous to the one that we're basically processing. Okay, so we say dividend.map, and then we're going to need an index of some kind. So we say with underscore index. And the next thing we have is an open brace. And then what is in a dividend? The way that we've defined it here, you should be able to answer this before I do. I was talking about, okay, so what is the dividend here? It's an array of coefficients, right? Which represents the polynomial 3x cubed plus 2x squared plus 5x minus 9. Okay, so it has coefficients. So why don't we call what we're enumerating coefficient? Okay, and then we have an index. So why don't we call this, let's say IDX for now? All right. And what we're now going to do is we're going to now address, well, what is it that we're computing, right? Well, we're actually working within this buffer-like thing. I don't know if it's called buffer or whatever, but the whole point is it's this temporary space that's analogous to the array that we're throwing into map. And it's going to basically give us an output that that's basically in the same space as as each element of that array. So it's like one-to-one. We have this one-to-oneness going on. So the first thing we want to do is our first result is to go into this quotient array, which actually our output is supposed to look like. And the first, when you index it at 0, it's to give the quotient is to basically resolve as the same number, okay? And that's going to happen because we're multiplying the divisor by, let's say, 0, right? We're adding the dividend to it, and then we have this, but there's no quotient 0 minus 1, right? There's no, the index starts at 0, not at -1. There's no -1 index in an array. But we can basically leverage the behavior of Ruby to give us the behaviors that we want. So what I would like to do here is I would like to say something like result. Let's just put result here. And I want to equal, let's put, we want an array in the end, right? I mean, what we're looking for now is the quotient. And I'm now relating quotient with result. Now I know what I'm trying to do now is I'm trying to reduce everything and make it real simple. You'll see exactly, well, I'll be able to appreciate what I'm doing in a moment. But anyway, since result, think of it right now as I'm doing this as result is relating to the quotient that we're actually constructing. The first element that we want to grab in our construction should be 0, so that when it ultimately works out beautifully in like one line in the next line. You'll see in a moment. So I'm going to instantiate result as an array with one element, and it's going to include 0. Okay, so the next thing we want to do is we're going to define the element of the array that is being that we're constructing from dividend, right? The one-to-one mapping. We want to say result, and then we want to say the index. So we say IDX. Okay. Equals. We want to say, again, we're multiplying the divisor times, so we're multiplying it with the result of index minus 1. Okay, result. Indexing it at IDX minus 1. And we're adding to it should be the dividend, right, at index. All right. Now, we have something pretty interesting here. As you could see, okay, so at result, okay, at result of 0, right? What we have here is the divisor multiplied by result, which is index 0 minus 1. So we have result minus 1. When you see a negative 1 in braces, it means take the last element of that array. Our array here is result, and the last element would be, well, the only element here is 0. So we automatically have, and then we wanted to make sure that it's added to the dividend of the index at that place. And so since the index, in the case that we're talking about at index 0, we have the dividend at index 0 is our first result in index 0. Exactly what we're looking for. When you take a look down here, that's what we're looking for. We're saying basically, okay, here's the first element of that we're trying to construct of our quotient. So this is the thing that we're constructing. This is what we're given, and this is what we're constructing. Okay, and this is the work, some of the work in doing this. This is what you'll see basically whenever you see a description of synthetic division. This is the algorithm that you do by hand. All we're doing right now is automating it using Ruby. Okay, so as you could see, the first case, the edge case, which would have been a problem otherwise, if this behavior wasn't here, it is here, so we know we can exploit that. That's why this is actually kind of beautiful, because I think that the folks that engineered Ruby, they were looking for ways of basically simplifying things that you should be able to do. The edge cases are usually the ones that create all sorts of havoc, whereas the rest of the algorithm is very simple. It's the edge case that makes you cringe, because you have to deal with issues of, what happens at 0, that kind of thing. But here it works out really nicely because of the feature that we have when you have an array and you're grabbing the -1 out of the array. There's a feature there we're actually going to be able to exploit here very nicely. Okay, so this is great. We now have our, after having gone through all of the coefficients, we would now have our quotient array. But it's not just the quotient. We have the quotient and the remainder. Now, what we're going to do now is, okay, this is not anywhere, right? So what we have to do is basically assign this, or else it kind of gets lost. So we're going to assign it to result. Okay, let result be this. Okay. Now, I want now to deal with the issue of how do we print out all this stuff? Okay, so we have an array, but we're being now asked to print it out so it looks nice like this and like this. So I created two, in my mind I'm going, let's create two functions, one that manages this and one that manages the other one, so that it kind of simplifies what we're trying to do. So the first thing we want to do is we would like to create, okay, let me just kind of end this right now. I'm going to add features to this in a moment. Okay, so before we actually make the stuff, I think I'm just going to print everything out. So the next thing I'd like to do is say, now that we have result, okay, first of all, let's take a look at what we have. The first line result is an array, right? And it grabs this array, it does what we want it to do. Ultimately, we're given an array, okay? Okay, so this should be, result should be an array still. What we're going to do is we're going to say print, because now we want to print the first line, so say print, first. And we want to say print first and put result in it. Okay. And then we want to have another one that says like print second or something like that. And then result. Okay. So in print first, what I'd like to do is, oh, it's not result. We already are making some errors here. In the first line, what we wanted to do is address what is the dividend that we were given. So this is our given. So instead of that, instead of result, we need to send it dividend, right? And then in the second one, we want the quotient and the remainder. So, oh yeah. This is what we want to do. What we want to do is now create a representation of the array as a string. So we want a neat string that represents what the polynomial looks like. So we're trying to print this out and make it pretty. So I think what I like to say is, instead of print first, I want to go, let's print dividend or something like that. Okay. And then I want to, the next thing I want to do is print the quotient. So let's do print quotient. Okay. All right. So print dividend, we have to start writing that. So you have to have some code courage here. So as I'm saying, as you're doing this, you realize that the code is actually telling you what to do, so you don't have to be afraid. You really don't. It's actually telling you what to do. So say def print dividend. Let's try that since it's helping us out here. And what do we take? What are we taking? We're taking an array. So we should just call it array, right? And that's in that. And what are we doing here? Well, the thing is, look at what we have with our polynomials. Okay, so if we're going to index, it's not 3x, 2x squared, 5x cubed. It is 3x cubed plus 2x plus 5x. Sorry, 2x squared plus 5. It's 3x cubed plus 2x squared plus 5x. So x cubed, x squared, x, and x to the 0, which is 1, times negative 9. That's what we're looking for. So you might, when I'm going to use map again, but I'm going to, since we're actually taking the numbers that are associated with the indexing, that gives us an idea that maybe within our while loop, we're actually going to need something like a map, right? We're gonna, we're gonna do index and we're gonna use map. So please excuse that my computer was sort of like doing something that it shouldn't have been doing. All right, so what we're gonna do right now is we're gonna say size, okay, equals, let's say array length, okay. And the thing is, remember we had an array of length 4 for an equation that was of degree 3. So that means we need to make it, we have to reduce it by 1, okay. And what we will do is array dot map dot with index. And we're gonna, what is in our array again? Okay, and this is of coefficients, right? Coefficients, so that tells us what to do. That's what I'm trying to say. That's why this is not so difficult. So let's call it coefficient 1, because we call the other original one up there coefficient. I think I don't want to name things the same. And since we have index, we have to add an index. So let's call that idx1 or something like that. All right, so now the next thing we're going to do is we're going to use print dividend. What we're doing is we want to turn this whole thing into ultimately a string. But map acts on arrays and gives us arrays. So you'll see exactly what it is I'm doing ultimately. But I realize that this is going to ultimately give us an array. We're going to join it at the end to turn it into a string. But as for now, this is what we're going to do. We're going to say at each of these, as we're enumerating each of the elements of array, the first one, right, or each one is going to be treated as this. Coefficient, 1, and we're going to we're going to go, okay, so coefficient 1 is a number. So right now, we should address that issue. So we should turn it to string, or else we're going to have some issues. All right, so we're going to add this to x because we're printing stuff out. So let me just go back down here to show you what it is I'm doing. All right, we're trying to get something that looks exactly like this. It's not something that looks like, we have to make it look exactly like this form. That's what I'm asking for. So we have see, the first is a coefficient, the next is x to the size, right? And then in terms of, that's what's going to look like. It's not just size, it's a lot of other, it's a few other things. We're going to do that in a moment. And then okay, so coefficient 1 to string x, and then what is this? We're going to have to break that out. Should have done this instead. Big error. Okay. So the next thing we want to do is plus it should be size or index. Size minus index, right? And size minus index is a number. So we might want to do something like this. Let's say toString. Okay. So we have the coefficient, which is 1 is a number. We turn it to a string. We say plus x, and we want it to be concatenated. That's why at the x I just have it like this with no spaces around the x. And then the other thing is size minus index 1. See where we have the error again? 1. Okay, so we fix that up. That's to string. Okay. And then what else did we want? We want, okay, so it goes through whatever it goes through, and then okay, this is good. Okay, so all we wanted to do is concatenate this, the expression of okay, the coefficient plus the x to the, and then we have the basically each of the powers, right? And the powers have to go down, and so size minus index allows for that. So size in this case, which is 4, so 3, because it takes the array length, minus 1 is 3. The first index is 0, so the highest power will be 3. So this works out. Okay. Now, what we want to do is, now that we have something, an array that looks like this, right? It looks like this, but it has the other printing stuff on it. So we just print it. What we want to do right now, okay, what we could do is we could join them, right? And so how do we join that? Since we have the pluses, we can just go dot join and then do something like this. Put a plus in there and make sure that the plus has some space around it, like that. So what happens is now we've created a string from this array of coefficients, and in between each of those elements of that array, we've put this plus with the spaces. So now we have something that looks like this. Okay. And that should work. So let me just go back down here. Oh, we want to say kind of like return this. Okay, so now we're returning a string. So it takes an array, it returns a string with it processed this way. See? Okay. Now the next thing we want to do is say def. What is our next function? Oh, print quotient. All right. Oh, sorry. All right. Now where is the quotient now? We just computed the quotient as result. So right now what we'd like to do is get access to this result. And all we need basically is everything up to the last element of the array, because the last element of the result array is the remainder. Okay, according to the process of synthetic division. Okay, so again, what we want is something of this form, right? Something that looks like this. So our print quotient is going to do basically the same kind of thing. So when take an array, do basically the same kind of thing. Our size equals array dot length. And it might be like -2 because our quotient is going to always be of a degree 1 less than the degree of the dividend. So let's say degree of our dividend is n, the degree of the polynomial of our quotient is going to be n minus 1. So we know up front, let's make our size array length -2. Then the next thing we want to do, since this is basically following what we just did, kinda, for now, let me just put end in there. Start off with what we know. Okay, and then the next thing we want to do is say, let's start to compute this. It's probably return anyway, but let's just do array dot map dot width index. It's probably a better way of doing this, but it doesn't really matter. What we need to do is just start acting. I wanted to provide as many opportunities to trip up as possible and still basically get to the point. I don't want to overdo it, and this is at the edge of overdoing it because we basically did the same kind of thing in print dividend above, but I just want to there are little differences in things here, and I think it's important to go over that. So let me just, since in our array, which is of a polynomial, is representing a polynomial, what have we been using to represent polynomials. We've been taking arrays of coefficients. So let's call this, of course, coefficient something. So coefficient 2, and then this is called index 2, because we just want to kind of keep it like we were doing before, above. And now, what does this look like? Well, it really should look like what we did below, because we're not really asking for it to do anything different. Okay. But it is different because we're dealing with this differently. And remember what's happening with the end of this. The last element is the remainder, and so we want to kind of like keep that in mind. All right, so what we need to do here, we know there's an error here because I repeated at least 2 times that the array that we're using that gives us back the quotient, we need, let's grab this, the 0th to to the penultimate. So we need the 0th index to the penultimate, in other words, the one before the last. That gives us the, that defines for us the coefficients of the quotient. And so we need that first, and we need to separate that out. So that's the first part of this. Then we're going to basically define things as we had in print dividend. So as I'm saying, the code is telling you what to do. So this is where your code courage is coming from. Your code courage is coming from information you already have, and all you're doing is just regurgitating a lot of it. And just basically just relax and let the code tell you what to do. So we have coefficient, let's 2. Make sure we're using the appropriate names here for the things that we're enumerating. Okay. Then plus, and then we do our, since we're printing stuff out here, let's continue this out. Okay. And plus, and we'll do size minus index 2. And then we say toString, because we have to. And we're going to do as we did before. We're going to join this, and we're going to use the plus character for that. Oh man, this always some stuff going on here. All right, so, and yeah, all right, so we have what we require. We needed to basically grab all of the we want to grab all the elements of our array except for the last one. We wanted the size to be 1 less than the one that's in our dividend, and it should give us this. This is what we're looking for. So now that we have print dividend and print quotient, we can now start printing out. We're getting towards the end of the process here. We just wanted to make this look nice. So we need to add to the string this. So let's do that. So we should say first line equals. First line is a string. We're just using that to help us out clarifying what it is that we're doing. So we call print dividend to give us a nice, a nicely formatted polynomial. Okay, then we're going to add, let's see, So the next thing we do is going to add to print dividend, we're going to add, again, see the code is telling us what to do. You have to look at the instructions. Whenever you have any kind of question as to how to proceed, go back to the instructions. So what we want it to look like, okay, let me just grab this out because that's going to help us here. Okay, I'm just going to paste it. It's not how it's going to be, but yeah. So, all right, we want to say equals. So what we need is a space, because what's happening here is if we don't put a space, it's going to kind of do what it does. So it's just going to concatenate, and it's not going to look the way we want it to look. So let's put p of x. This is just text, just filler kind of stuff. But I think it's important to do this because we're mixing up stuff here. And this is where a lot of errors are going to happen. So that's why I wanted to proceed with this. Now, the next thing you want to do here is you want to add the divisor. So, but it's not just divisor. Remember, divisor is a number, and this is a string. So you're going to have to coerce this into a string. And the way we do that is 2_s. Okay. Then we add that to this. The end, the parentheses, and then we say plus, and then we say r of x. Okay. So now we have print dividend, which is our nicely printed polynomial. Okay, that gives us, of course, what we came here with. Okay, we basically have p of x. We have equals q of x minus whatever our divisor is. Make sure the divisor is cast or is coerced into a string, and then we need to basically ensure that we have all the other properties here for the proper printing out. All right, the next thing we want to do is type second line. And second line is basically print quotient. Print quotient, and we want to send it the result, right? Okay, that should start giving us what we were looking for. But we're not done. Okay, so let's go do what we did before. Go back down to the rules. Grab out the next line. Let's go back up. All right, this is what we require. Just move this down. Okay, so we need to now say is quotient. So let's put a space, is quotient, comma, q of x. And then we want to say x minus, and then we need to put in, oh no, why did this happen? Well, we need to put in divisor to string. Okay. No, divisor to string. Okay, so is quotient q of x, then period, then x minus the space, divisor to s, which is what the divisor is. Then we want to say, close that, and then we want to say is divisor. Okay, but we're not done. Then we have our remainder. So what is our remainder again? Our remainder is result -1 dot toString. Okay. Okay. So we say 105, and then we say, put a space there, is remainder R. Okay, that should be it. Let's get rid of all the stuff here. I just wanted to, all right, and let's get rid of that. All right, so what's going on here? The first line gives, this is a string, second line is a string. Now what we're going to do is we're going to put this stuff out there so that we can actually get the result that we see here. So I would say puts first line, and then puts second line, and that should be pretty much it. Okay, so many places mistakes can be made, and so I think I'd like to go over this once, and then that's about that. Okay, so the first thing I want to do is I'd like to say that we began with result being 0. We're going to go use the map function with index. I'm going to grab our coefficient because everything in the array is a coefficient. This should come out right. And then I think, if anything, if we have any errors, it's probably going to have a lot to do with how we're printing everything out here. But print dividend, when you send it dividend, okay, does it even know what, yes, it knows what dividend is because it's coming from here. And print quotient knows what's going on because we just created result. It knows what divisor is because, again, it's coming from here. This is all supposed to resolve to string. So this is a string, this is a string, this is a string, this is a string. So first line should be a string. Second line, we know we want a string from it. This should result as a string. This is a string. See between this? This is a string, this is a string. This is also a string, and this is a string. Okay. Then puts first line, which is a string, puts second line, which is a string, and that's why it should be working. Now, in here, I think all of this stuff should be working. And okay, because what we're able to get the length of an array. This array, of course, is coming from this is a dividend, and we're breaking it up, and we're joining it at the end, which takes this thing, this mapped, mapped array into, turns it into something we can use. All right, this should work. All right, so let's test it, finally. I went through this thing very slowly and methodically, so it should work. But anyway, let me save. I haven't been saving things. What is up with me? Okay, save. Okay, so we save this thing called synthetic division 0, and what we're going to do right now is we're going to say Ruby and synthetic division 0.rb and see what we get. Okay. That is basically what we're looking for. Okay, let me just put a space in here somewhere. Let's put something like that, right? So put an empty line or something in there. Oh man, let's run that again. Okay, so is that giving us what it definitely should be. Okay, so the first one, that's exactly what we're looking for, right? It looks exactly what we're looking for. Let me just bring this up and show you again. And then the second one, exactly. And notice, you should all notice if you if you dealt with quadratics before, you should recognize this. There's x minus 3 times x minus 3, right? So x minus 3 times x minus 3 gives you x squared minus 6x plus 9. So that should turn out right, and there you go. Okay, we get, when we divide by x minus 3, we get x minus 3, and the remainder is 0. So there you go, ladies and gentlemen. Be code courageous and let the code guide you. Don't be afraid.